Hi, I'm Chris Pudney at the University of Bath, and today we want to really showcase a technology we've developed for instantly detecting synthetic cannabinoid receptor agonists, sometimes called SPICE, on pretty much, any or a very vast range of different materials. So what we want to do today is, I know a lot of you have seen the development stages of this device, but really in one video, show the detection that we have on a bunch of different materials. So for some context, spice is a drug that's really commonly found in prisons and also in homeless communities. And one of the things that really drives its use is that it's very difficult to detect. And so entry to prisons is very commonly on things like soaked into paper or in this kind of herb material that we see here, or even soaked into fabric and many other routes. And so the challenge of detection becomes, can we detect spice on a very broad range of different matrices? And one of the other things that I think is challenging that's coming through, we're increasingly seeing recreational drug users who think they've got, for example, vapes with cannabis or THC in, and it's actually spice, and that's certainly been putting people in hospital, and that's a bit of a worrying development. So we also want to be able to detect in even more complex matrices, so things like vape fluid and possibly even gummies and other things. So this is our device that we've got here, and maybe we'll go into the technical details another time, but essentially we've got a blue ring and it's going to go red when we're actually detecting the drugs. So the first thing we want to look at really is this kind of herb materials, which is what we call street material, and it's designed really to look like cannabis even though it's not. So in the top here we've got material that has got no spice soaked onto it, and even some cannabis on the far side there. So we shouldn't be getting a signal for spice from our device here, and in fact we're blind, if you like, to cannabis, so it doesn't confuse our signal. So let's go over the top of these now, and indeed we just get our little blue lights that say we're working over the negative material and over the cannabis material, so no red lights, so no spice present. If we now look at these material down here, these are actually seized by the police, and they are qualified to have spice on them, and different kinds of spice, and we can very quickly see, we pick up this red ring of lights on both samples, and the lights running outside are giving us information on the amount of spice that's present. So more on the outside means higher amount, if you like. So what about paper? Paper is a really common route of entry of spice and other drugs into prison because it's really easy to soak onto paper. So both in the postal system and as throwovers and other means, it's just convenient. So this piece of paper was seized in a prison and was suspect, and some holes were chopped out to see if it had spice on it, but there's nothing on this. We've qualified this by NMR. There's no drugs on this at all, and we can see that we don't get any red lights. It's just blue, nothing present. If we take now maybe a more obvious sample that very much does have spice on it, qualified by NMR, immediately we get full red rings. There's really a very large amount of spice on this sample. So maybe if we look at something that's less obvious, so something that just looks like some folded up paper, and again this does have spice on it, and we can see immediately, we can detect that, and actually it's at a very high concentration again. So paper, that's kind of real examples. I wanted to show the example of looking at different concentrations and that instant detection of the material, and also the concentrations that we can see. So this piece of paper has a range of different concentrations doped throughout it, and what we can see now is kind of our signal level going up as we go on to higher amounts of material. But notice that the detection is truly instant, and we can transition between those different concentrations truly instantly. So that's a different example now. And there's kind of our highest concentration up here. Maybe even more challenging than that, and maybe relevant also to entry into prisons, is fabric detection. So we want to look at spice on a range of different fabrics. So here's some white cotton, and we've placed some spice, somewhere on this. I know where it is. So to start with, we'll just look around where it's not. So just our blue rings here, so not detecting anything at all as we scan around. Then as we scan over the spice, we pick it up again instantly, we can see that on the white cotton. If we look at something more complicated now, so here we have a kind of a grey, almost toweling material, a bit like a tracksuity material. And if we just look where I know there isn't any spice on this side of the material here, again, we get nothing. And as we flick it over and we look where I know it is now, okay, we pick up that material, and again, instantly, but something very different to the white cotton. If we look at something even more challenging now, which is a pink toweling type material, really complicated, difficult matrix, very absorptive, obviously. And as we go on here, you know, we pick up the material absorbed into here very quickly, and it's kind of absorbed all across. Now we get a few positive regions and a few negative regions throughout this piece of material. You know, if we think about maybe flipping it over, and again we get the negatives, but we can see if we come over here, I suspect, yeah, soaked through over here, and we can pick it up on either side. This is very complicated material, all very different. So I said that we do increasingly worry about use in the community, particularly in vape fluids. So here we've got an example of two different kinds of vape fluid with some different spice molecules in them, different colours of vape fluid and different spice molecules. And we've just put a very tiny amount on some filter paper just for ease of us looking. So we've got the negative control and then the vape with the actual spice in it on here. So if we go over, this has got spice here, and we can see instantly we pick up the presence of the spice in the vape. And then if we go to the control sample and place it over that, we see nothing, even on this kind of oily vape liquid. Again, this control now of this clear coloured vape liquid, we get nothing. And then as we move over to the clear coloured vape liquid with spice, we can see that, you know, we're picking it up absolutely immediately. So that's a really broad range of materials now that we can see these drugs across. And I think that's the key point here, is that the entry of these drugs into communities and into prisons and through users is very varied in terms of the materials. So even things as complicated as kind of toweling-like materials. And we need to be able to detect on all of those different matrices. And I think that's really what's unique and special about what we have here, is we're able to detect on all of these different matrices and absolutely instantly, transitioning smoothly and instantly between any of these matrices. So we can really now both think about the use of this technology for harm reduction and to prevent drugs entering, for example, the prison system. So thank you for that, and we'd be pleased to take any questions. As ever, do just contact us.